Okay, so what we have here is the squeeze theorem. So uh, I'm gonna start off with, let's say, this here. Let's say, okay, so let's say proof. So read through the theorem, make sure it makes sense. Okay, we have that basically if g of x is being squeezed by f of x and h of x in some open interval containing a, so all this inequality is true for all the x in some open interval containing a, and we have that the limit as x goes to a of f of x is the same thing as limit as x goes to a of g of x, and they both equal L. Then, oh, wait, no, not h of x. No, I wrote the statement wrong. Good, you see, that's h of x, sorry. Then g of x goes to L, I apologize. So this is h of x. The limit as x goes to a of f of x is equal to the limit as x goes to a of h of x, and they both equal L. This squeezes g in the middle, so that way the limit as x goes to a of g of x is also L. Now, the proof of this. What we want to use is we want to use basically the three facts here. 1, 2, 3. Okay? And we could use those three facts to guarantee that this limit here is L. And remember, we always want to show that for all epsilon greater than 0, I can find some delta. There's going to be some delta, and it really depends upon whether or not you can find this delta. And I'm going to demonstrate where this delta is. I'm going to say, this is the delta we need. That will make it true for any epsilon. So I picked any epsilon greater than 0. There exists some delta such that we know that for all the x in this set here, all the x that make this inequality true, it will immediately mean that g of x is within epsilon of L. Now, I want to show this. This is what I want to guarantee. I want to say, where is this delta? Okay. So what is it that I'm gonna do? I'm gonna say, okay, well, this here. I don't know. I picked one of these three facts randomly, but we could demonstrate anything. For let's say f of x as x goes to a equaling L. Right now, if that's true, what that means is that for any epsilon greater than 0, there exists some delta 1, right? So let's write this fact. So for epsilon greater than 0, this epsilon particularly, there's going to exist some delta greater than 0, and let's call it delta 1. There's going to exist some delta 1 greater than 0, such that if, again, x is within delta 1 of a, any x within delta 1 of a, this will immediately imply that f of x is within epsilon of L. Okay, and this is really just going to this inequality we're going to rewrite. So this implies, right, negative epsilon is less than f of x minus L, and that's guaranteed to be less than epsilon. Uh, and this immediately implies this one here, which is that if I add L on both sides over here, I'm going to get L minus epsilon is less than f of x. And then this one, if I add L from on both sides of here, I'm going to get L plus epsilon. And what's key here is to remember that what is this saying? This is saying that for any x within delta 1 of a, I have this inequality being true. Now, why did I rearrange it like that? You'll see that at the end. But I could run through a similar argument, and I'm going to real quick, but faster this time, that for the same epsilon greater than 0, I know from this fact that for h of x, right, this is h of x, I apologize, it's h of x, I know that there exists some delta 2 greater than 0, that for all the x within delta 2 of a, I could make h of x within epsilon of L. h of x minus L is less than epsilon. And that's fine too, because then I can do the same sort of game that I did with these 3 steps. I'm going to do it in 1 step. Minus epsilon is less than h of x, and then it's less than L plus epsilon. Okay? And delta 2, for all the x that are within delta 2 of A, h of x will be within epsilon of L. And this inequality will be true. That's more important. What's more important is that I have this one. So let's call this one 1, let's say, or 2, whatever. Let's call it 2 because I did it second. This one's 2. This one's 1. Now, when is it that 1 is true? 1 is true for all the x that are within delta 1 of A. So if I choose something smaller, like let's say delta 2 is smaller than delta 1, then this inequality will still be true, right? Because then x is still within delta 1 of A. If delta 2 is smaller, it's then within delta 2. Okay, so if I choose the smaller between these two, then both of these will be true. The last statement is a little weird because we don't see it written very mathematically. We see it written more in words, and we have to really understand what this means. It just means that this inequality is true for all the x in some open interval containing A. So this is some open interval containing A. Here's my interval, or here's my number line. I have A right here. Some open interval containing A is like this. This is an open interval containing A. And for any x value that I pick in here, this inequality will be true. Now, that means that there's going to be some delta 3 on either side of this. Okay? And it's just essentially the length. Or we pick some open interval that's within that open interval that's of length delta 3. But we should be able to see that we can do this, right? That what this statement is saying, take your time with it, really digest it, but just know that I could always find some delta 3 on the either side of A that's going to make this inequality true. For all the x within delta 3 on either side of A, then this inequality is true. Now I have these 3 deltas. I have delta 1, delta 2, and delta 3. The minimum between them, I'm going to call that delta. So let's go over here, let delta be the minimum between these 3 deltas. So delta 1, delta 2, delta 3. And we should see that this new delta, the minimum between the 3 of them, is going to make all 3 inequalities true. It's going to make this inequality true, so let's write it. Let's write that inequality. So f of x is less than or equal to g of x is less than or equal to h of x. Okay, let's box it and call it 3. We should see that this delta is going to make all 3 inequalities true. And with all 3 inequalities true, let's add to 3. So I know f of x is at the end over here. F of x is less than or equal to these. So if something's less than that, then I could put the less than on the other side. So I'm going to put L minus epsilon is less than f of x, which is less than or equal to g of x, which is less than or equal to h of x. Okay, because I just combined 2 and 3 there, right? I just used the fact that L minus epsilon is less than f of x, and then I used this one here, and I rewrote it. Now I'm going to use 2. I know that h of x is less than L plus epsilon. So I'm going to rewrite it. I'm going to give myself more space. I'm going to say L minus epsilon is less than f of x from this one, which is less than or equal to g of x, which is less than or equal to h of x, and then I know from 2 that h of x is less than L plus epsilon. And then, immediately following from that, right, g of x is between these two. So I don't need this. I don't need this f of x. I don't need this h of x. This guarantees that L minus epsilon is less than g of x. And g of x is less than L plus epsilon. Rewriting this by minusing L on both sides of this, I'm going to get negative epsilon is less than g of x minus L, which is less than epsilon. And then this one is just the statement of that the absolute value of g of x minus L is less than epsilon. And now I've demonstrated some delta. I said I'd find some delta. I found a delta, the minimum between these three delta, this delta here. The minimum between these three delta that would make all three of these inequalities true would guarantee that g of x is within epsilon of L. And at this point, you're done. This is the end. You could write that this implies immediately that the limit as x goes to a of g of x equals L, and you're done.